first let's talk about what a function is, and then that'll make more sense why we need a function. So a function is technically it's just an idea. It's an idea to have such a thing. So let's say if you have such a thing, let's call this a function. So this could be your function. And the idea is to have such a thing that when you give it an input, it basically gives you one and only one output. That's the idea. So this is the entire idea of what a function is. And that's pretty much it. There's really no secret to it. You are trying to put in something, and for that something that you put, you are trying to get one unique output. So not two, not three, not more than that, just one unique output. That's really important. That's all a function is. That's where a function is different from an equation. So an equation could be something that could give you two answers. So when we do see, if you have something, let's say y squared equals let's say 3x, right? And you take the square to the other side, this will basically just be plus minus under root 3x. So this would actually not be a function. Why? Because it gives you two answers. It gives you one answer for the positive sign, one answer for the negative sign. So this in fact would not be a function. If this was a function, then you would either choose just the positive sign, the positive under root, or you would just choose the negative under root. So then that would be a function. So that's all a function is. Now, something else that you can see happening in a function would be, let's say, if this is your function, perhaps you could have two inputs. Let's say you could have an input, let's say A, and let's say you can have another input B, and both of those give you an output C. That's still a function. The reason is because for if we just talk about A, then you're getting a unique answer for A. If we talk about B, then you get a unique answer for B. If this was the case that you put in B and you got C as well as D, then that's not a unique output. That's not a unique answer. Now there are two answers, so that wouldn't be a function. So that's all a function is, and this concept is really important that anything that gives you more than one output, that's not going to be a function. This concept is really important. Now the question is, we know what a function is. The question is, why do we even need a function? See, with an equation, you can, as I said, you can do math, but the thing is, you would get, let's say, if again I take the previous example, you would get something like this. You would get these two answers. But now, when you're sort of applying math to real world situations, you're computing with math, you're doing calculus with math. You guys will study calculus when you do integration and differentiation. When you do all of those things, the problem is that an equation is not as predictable. And as you get to your more advanced studies, maybe in university, maybe in your A levels, if any of you take further math, this will sort of start becoming more and more obvious that functions are more predictable. They only give you one output for each input. So they are more easier to predict. It's more easier for humans to tell how a function will behave as compared to how an equation may behave. That's one of the reasons. The second reason is that a function states how one quantity, your output quantity, depends on the input quantity. It states that very formally and very clearly. And you're going to be like, well, how does it do that? Well, when we talk about function notation, I'll just give a brief overview about how functions are written formally. They're not written like this, clearly not. They're written more so like this. So f of x, where this right here, this entire thing in blue is your function, and then this basically this x in here is the input. So what does this say? So this says that this is a function f. So f is the name of the function of x of x. So what does this mean? This means that we have a function which is named f. F are basically going to be all of the output values, and they depend on another variable that we are calling x. So it really formally states that if you know how to read the symbol, it really formally states that we have a function which is called f, and it depends on this other quantity called x. You can see you can write an equation like this, so you can have y equals 3x plus 2, but it doesn't sort of formally state that in a cool way, right? Mathematicians love symbols. This thing right here does the job.